Hey everyone, welcome to this explainer. I am seriously thrilled you're tuning in today. We are tackling a super critical, high-stakes piece of commercial and industrial infrastructure. We're going to dive deep into a comprehensive busway installation guide, zeroing in specifically on joint torque, alignment, and testing. Now, if you spend any time around large-scale electrical installations, you know that the busway is absolutely the central nervous system of power distribution. But as we're going to see, getting the hardware to the site, well, that's really only half the battle. I want you to really think about this mystery for a second. What actually causes a perfectly rated busway to just fail an inspection? I mean, picture this. A site gets a delivery of this top-tier busway system. It's got the correct current rating, the perfect conductor materials. The support layout is mapped out flawlessly by the engineering team. And yet, inspection day arrives and the system catastrophically fails. How in the world does that happen? So, here is our roadmap for today. We're going to cover the crucial joint, alignment before torque, real quality assurance, testing insulation resistance, and finally, surviving neighboring trades. Let's jump right into Section 1, the crucial joint. Okay, the absolute fundamental truth of this entire explainer is that busway installation quality is ultimately decided right here, at the joints. There is this intense, almost wild contrast between flawless factory specs and chaotic field reality. On one side, we have the engineer's dream, right? Correct current rating, perfect conductor material, proper support layout. But all of that beautiful, perfectly engineered factory precision is literally rendered useless if it doesn't survive the field variables. Your installation has to survive proper joint alignment. It must survive joint pack cleanliness because honestly, even a tiny speck of debris can cause a total disaster. It has to survive the exact torque sequence and, of course, pass installation resistance testing. If these field variables aren't strictly controlled, your flawless specs just don't matter at all. Just to ground this in some real-world authority, let's look at the Shinma quality baseline. Shanghai Shinma, busway and cable tray manufacturers products that comply with massive global benchmarks. IEC 614396, IEC 61537, NEMA VE1, and GB 31251 standards. Now, when you're working with equipment that meets these kinds of rigorous international baselines, you know for sure the manufacturing is pristine. So the failure is almost exclusively introduced during the assembly process on site. All right. Moving on to Section 2, alignment before torque. We're shifting our focus now to the actual physics of assembly. This is arguably the single most critical physical step on installation day. Proper alignment means bringing those busway sections together so they are aligned perfectly before you ever apply torque. You're setting the joint up for success from the get-go. But then there's the danger, forced alignment. And guys, this happens all the time in the field. Sections are slightly off and an installer decides, hey, I'll just use the joint bolts to aggressively force these misaligned sections together. No way. This is a massive, surprising, and all too common field error. When you use joint bolts to force alignment, you introduce extreme mechanical stress, you compromise the electrical contact, and you are actively destroying the integrity of the system before you even turn the power on. That takes us to Section 3, real quality assurance. Now that we understand the physical engineering risks, we're transitioning from the physics of it to human error. We're exploring a massive accountability trap that catches site inspectors out every single day. Look at this. All joints checked is not a usable QA record. Let that sink in. This lazy phrasing is an absolute industry failure. When a site manager looks at a clipboard and just sees all joints checked scribbled at the bottom, they know absolutely nothing about the actual safety and integrity of that busway system. It's just a total illusion of quality assurance. Think about it like this. A bad QA log is your generic checkboxes, your lazy all joints checked notes. It is essentially useless if something goes south and you actually need to trace the failure. A good QA log, on the other hand, involves specific location-by-location torque recording. You aren't just saying, yeah, I checked the joints. You are recording the exact torque applied at exact mapped joint locations along the busway. This is literally the only acceptable quality assurance method because it creates a permanent, verifiable record of the field installation. Section 4, testing insulation resistance. So we've talked about the physical bolts and the paperwork, right? Now we're transitioning into the invisible metrics of a busway installation. These are the tests that truly dictate final success or failure. You'll often hear people panic over a low reading during an insulation resistance test, but let's demystify this technical jargon for a second. What is a low reading actually telling you? Well, a low reading is an indicator of field installation issues. It means you likely have poor joint pack cleanliness, maybe some dust or debris got in there during assembly, or perhaps there's moisture trapped inside the system. Actually, scratch that idea that it's a product defect. It is very rarely an inherent material failure of the busway itself. It's really just the system waving a giant red flag, telling you that the field environment compromised the hardware. To properly conduct this invisible verification, there are two exact parameters you absolutely must control in your protocol. First, you have to identify exactly what to measure. Second, you must know exactly when to stop testing. Controlling these two parameters ensures your testing is accurate, safe, and actually gives you the diagnostic data you need to verify the installation's integrity. Almost there. Section 5. Surviving neighboring trades. We are near the finish line, but there is a major plot twist here. You might be thinking the job is done just because the electrical installation is finished and the testing is complete. But the true danger might just be walking onto the site. Here is your post-installation threat timeline. Step 1. Installation day is complete. You've aligned everything perfectly, torqued it right, recorded your QA log, passed your resistance tests. You feel fantastic, right? But then comes step 2. Neighboring trades finish their work. The HVAC teams come in, the plumbers arrive, the ceiling grid installers get to work. They're moving heavy equipment, running their own lines, and inevitably they might bump, shift, or compromise your pristine busway. Safety is an ongoing timeline. That's exactly why step 3 is entirely non-negotiable. Final access and support checks must be conducted after the other trades have left the area. You have to verify that your support layout hasn't been altered and that you still have access to the joints. So why are we so obsessive about this entire framework? Well, because we are talking about data centers, rail transit, industrial plants, and massive commercial buildings. These are high-stakes, zero-downtime environments. Shinma manufactures not just busways, but cable tray systems, seismic bracing, and intelligent cable management solutions specifically for these demanding spaces. When you're powering a data center or a rail transit line, a joint failure isn't just a minor inconvenience, it's a catastrophic operational and financial disaster. Strict adherence to this installation framework is totally non-negotiable, for sure. Which brings us to our final thought. Ask yourself honestly about the projects you work on or manage. Are your site's joints the strongest link? Are they properly aligned, cleanly assembled, and meticulously recorded? Or are they a failure waiting to happen because someone forced a bolt, skipped a cleaning, or just scribbled all checked on a clipboard? The true quality of your busway is decided in the field. Thank you so much for joining me to unpack this guide. Keep learning, keep asking questions, and I'll see you in the next explainer.